Welcome back for Math 205, and today we shall study 5.4, which is the application of Laplace transform to solve initial value problem. In this section only I will introduce something which is about the properties of the Laplace transform, which we study it, and this is the most important property for the derivative of a function here, you see. Okay, so before we start solving exercise here, because application just we want to solve differential equation by using the Laplace table which we introduced before, and this property. Okay, why this is very important property? Because if you think about f is just y, the solution, so if you substitute here y and take n equal to 1, so L of y prime is just this one, SLY minus y of naught. So y of naught, we have it, it's the initial condition in our differential equation, we substitute for it. And for n equal to, this property will give you the second derivative, L of the second derivative of y, and it will be three terms here, as we see, s square Ly minus sy of naught minus y prime of naught, and this is the fact that we have the initial condition for second order. We have y of naught, we have y prime of naught. For the first order, we have only y of naught. So if we go for n3, if you want to calculate L of y3 prime, you get four terms, s cube, you substitute n3 up in this condition and this property, and you get the fourth term here. So it will be coming also y double prime of naught 3, and if you put n equal 4, you get the fourth derivative here, you get 5 terms as is given, and so you can write L of fifth derivative, sixth derivative, so as like that. So this property is very important because when we apply L for both sides of equation, we get L of y prime, maybe we'll get L of y double prime, it depends what we have in the left side of the differential equation. Now we shall solve an exercises for the initial value problem. Okay, this exercise is 5.4, which is talking about, okay, solving initial value problem using Laplace transform. So usually it will be say that solve this differential initial value problem using Laplace transform. So this is the initial value problem here. It's written. Okay, so the second order differential equation, and you have y of naught and y prime of naught. So take L both sides for the equation. So L of y double prime plus 4 L of 4Ly, and as we know L is linear, so 4 goes out, and here L of 4t will be 4L of t. So this is your differential equation, I write it star. Now we go to the previous property as I said, and this is L of y double prime. So we substitute here for y of naught and y prime of naught. Y of naught equal to 1 and y prime of naught equals 0, so we get equation 1. Okay, so this is Ly double prime. Also we have in the left and the right hand side L of t. L of t, we get it from the table. We go and calculate L of t will be 1 over s square as given by 2. Now we substitute from 1 to into star, so it will give us, this is your star here, Ly double prime, this is the 1, so we substitute here, so this is the Ly double prime, and plus 4 Ly is there, and L of t is equal 4 over s square. So take Ly as a factor between the two terms here, you will write then s square plus 4, and take this one to the other side and put it there, and of course you can put this as s cube plus 4 over s square, divide by this, you get L of y in this form. So now how you find y is just you take L inverse of all this. Let's go for the second page to find the L inverse. Now L of y, I write it again here, L of y. Okay, so y of t, this is y of t, will be L inverse of this. Of course, from calculus, we know how to calculate, and also in the beginning, I explained how we find a partial fraction of 2p over q, how we do it. So we separate, this is s squared, so it will be a over s, b over s squared, and here, because quadratic, we write it in this way. So we have a, b, c, d to calculate, and this is very easy to calculate. I already do it. You multiply here by that term, and then either you calculate the coefficient of the powers of s, or you put some values. So we get b equal 1, a equal 0, d equal -1, and c equal 2. Substitute back for these values here, and then to find y of t, you take L inverse of this. So I put a, so it will be a equals 0, it goes. B equal 1, so it will give us L inverse of 1 over s squared. And I separate this term to two terms, because one will give us cosine and one will give us sine. So I separate here. This is the first term, s, and c equal to 1. And I separate d equal -1, I take it out. And what's you get here? I put 2 in red, because here it's very easy. You can apply, this is from the table. You get L inverse of 1 over s squared is just t. Okay? And here you get cosine 2t, the square root from the table. And here you will get sine, but you need the square root of 4 up. So I multiply by 2 here, and I divide by 2 here. So in fact, this is what happened. I divide by 2, so I get the sine function, sine 2t from the table, and we have -1 over 2. So this is, we'll finish this exercise. As we see here, this solution satisfies the differential equation and satisfies the initial condition. Let's go for another exercise. This is exercise 544. Here we have exponential function in the right side. Again, initial condition we have at 0. And this is the second order. Again, we calculate L. We take L for both sides of the equation, as we did here, see? And we take the constant outsides. And again, we calculate this time Ly prime. We have y of 0 equal 4, so I put it here. We calculate Ly double prime, which is very important, I tell you from the beginning. So we need to calculate all these. So Ly double prime from the rules, I write it in the beginning. So we get, and then we substitute for y of 0 and y prime of 0, and we get here s square Ly minus 4s minus 2. So we get this, and here. So we substitute back. Don't forget also to calculate from the table all this. So from the table, you go to the table, when you have exponential, multiply by t to the power n, you get this one, n equal to 1. So n factorial equal 1, 1 factorial. And here s plus 1 to the power n plus 1 will be squared. Substitute back into, then star gives, when we substitute all these three things here, to star, we get this one. Okay. We take again, we shall take Ly as a factor between them, and we take all the others on the other side. So what happened here? This is what I did. I take a factor Ly. I get here s squared plus 2s plus 1, and this is, we can write it as s plus 1 to the power 2. Very easy. And here two terms, 4s plus 10 minus 3 over s plus 1. Then I write this is s plus 1, then I divide the other side. So I get this one when you divide it by that one. So you get this one, and here it will be to the power 4 because you divide by it. Now again, this is straight direct from the table, this one. But this one I do it partial fraction as I did here. It's very easy, linear repeated. And I calculate A, and I calculate B, and I find them. So this is your Ly now. After we substitute here for all these things here, this term plus this term here, it will come to that one. Okay, now we take y of t will be L inverse of the three terms. Each term, we take it alone, and we go to the table, for each term. And as you see in the last term, again, I multiply by 3 factorial and I divide by 3 factorial here to get it in this form of the table. And straight direct application of exponential, this is will give you for the first term. The second term, again, exponential multiply by t, because n equal 1. And the last one, t is equal, n equal 3. So 3 factorial up, I multiply and I divide. So I will get t to the power 3, e to the power minus t. So this will finish this exercise. Okay, and now as we see, it's very easy to calculate things. The most important is how to calculate the inverse, because y of t is coming from the inverse of all these function of s. And we use the table, we try to put it in the standard form. Let's go for another exercise, page, the second page. It's fourth order differential equation. I put it here. Fourth order, it's number 10. And it's given 4 condition for the initial. This is given. So I take L for both sides, here in star. This is L for all the differential equation. Now L of y4, as I did it in the table. This is from the table, all the form, from the property of the, which I write it for the derivative. Then I substitute for y of naught, y prime of naught, y double prime of naught, which is equal all zeros. Only the last term, which is y3 prime of naught, equal to 1. So it's very easy. We get this one for the fourth derivative. L of 1 from the table, 1 over s. Substitute in star back again for all these. We get very easy equation. See? Very easy equation. Take L of y as a factor between these two terms. And take minus 1 to the other side, it will be plus 1. And you can put it in this form. When you put here plus 1, it will be s plus 1 over s. And now you divide by that. You can factorize this. 2 square s square minus 1, s square plus 1. And then you can cancel the up 1 and you get this one. Okay, then what's y of t? Will be L inverse of all these 3 terms. And I leave it as an exercise. You can complete that by partial fraction. It's very easy. You can get the solution. The last example, which is very important, is when you have system of differential equation. This is example 5, exercise 5.4.12. It's 3 parts, it's written A. The A, it's given. This is a system. You have 2 differential equation here. And this is the initial, so system. So what's the solution? The solution will be x of t, y of t, in fact. It's a pair. So this is because a system of differential. We take L as we did for the previous example for the 2 equations. So we get this together. The 2 equation, we get equation 1. It's a 2 equation. Now, I substitute for Lx prime, again like y prime, just instead of y, we have x. So this is again the property of the derivative. And then I use x of naught equal to 1, so I get this one. The same for Ly prime. Okay. So y of naught here equal to 0, so I get this one. So this is will get Lx prime and Ly prime. Substitute back into 1. So I substitute back into 1 for L of x prime and Ly prime. I get 2 equation without, of course, this is Lx prime, it will goes. And then I take Lx as a factor and we substitute, and the one gives the differential equation. When we take the differential equation 1, this, we substitute, we get Lx prime, we substitute here, and we take Ly to the other side, plus the minus 4, so it will be Lx as a factor. And here, Ly is a factor in the second equation, I mean here. So we get a system of 2 equation, and Lx and Ly, like algebraic equation here. So now this is part A. We get only a system of two simultaneous equations. Now we need in part B to solve for Lx. Solve for Lx and Ly. So just algebraic equation, what I did here, I said multiply this equation by s plus 4 and add. This is the meaning of that one. Because I can cancel Lx. So when I multiply, and you take, so this will cancel out this side. So you have only Ly, and here it will be 1. And Ly s plus 4 multiplied by s plus 2. So you get this is inside equal to 1. So you get one equation. Of course, if you multiply here and you add, you get this one. It's very easy. It will be just completing sequence. Find L of y, it will be 1 over this. You divide by that. So this is Ly. So you solve for Ly. Now still we didn't find y and x. L of x, from this equation you get Lx, because you can, Lx you take it the other side, it will be x s plus 2 multiplied by Ly, and you have also L of y, you substitute in it and you get L of x. So you solve the two equations. Now how you find the solution for the initial value problem, or the system of the initial value problem, system of differential equation? You need to find y and you need to find x. And how you find it? You need the inverse. And this is what I did from the second page in part C. I put it part C. Y of t will be L inverse, and this is by the table direct. Okay, from the table you can get this is direct. And also x of t will be L inverse. You go to the other page and and here again you need to evaluate this by partial fraction p over q, and I put it for you here. And I evaluate a equal to 1 and b equal minus 1. And then I substitute here for a equal 1 and b minus 1. Then I take L inverse for this equation. After substituting, I get these two terms here, of course. And now I go for the table direct. It will give you e minus 3t, this one. And this one will give us minus t e minus 3t, okay, for that one. So this is the solution. In fact, x of t and y of t are the solution for the system, satisfy the system of differential equation and satisfy the initial condition for x of t and y of t at naught. And this will finish this section. Thank you very much for listening, and I hope I cover the materials for the inverse and how to solve the differential equation using Laplace transform by the table, and the inverse how we do it.